Okay, I'm being motioned. No flashing lights this time. It's the waving of the thumb. There's like a per theatre notification system. It's customized. I really like it. Okay, my name's Ian. With the evangelism team at AWS, I'm only going to be on stage for a minute just to quickly introduce this session. Talk about some of the things that have led to the partnership between Salesforce and AWS, and also led to adoption of AWS by the FT. But I'm going to quickly vacate this stage and hand over to David from Salesforce and Rick Still from the FT. He's going to take the bulk of the session and talk about FT's use case for Heroku in combination with AWS. So, as you will have heard in the keynote this morning, the fundamental characteristics that have led to the cloud becoming a popular target for development and deployment of applications are pretty well understood today. We see customers using AWS because they want to go faster, they want to free themselves from some of the constraints that are present and common within more traditional delivery models. They want to reduce costs, improve availability. And I think most importantly, dual factors actually, the fact that by using the cloud you can ride or surf on the back of somebody else's innovation wave and naturally take advantage of new features and services as they are delivered. And you can do the same thing for information security. These two attributes have become understood as really important benefits that customers can derive from using AWS. It's obviously led through feedback to the creation of a pretty large, pretty extensive catalogue of services with over 90 different offerings today. And integrating those services with Heroku and other application development environments is actually really simple. We have a service feature called IAM that a lot of you will be familiar with. It's AWS Identity and Access Management. And what we do here is allow you to establish multiple principals within your AWS account, multiple identities, if you will. These identities have credentials associated with them, and those credentials are used for request signing. So if you access a service using one of the AWS SDKs, you'll set environment variables or embed AWS API credentials and access in a secret key within your environment. And this access and secret key are then used for request verification and request validation. And actually there's nothing different about using AWS service primitives with Heroku to the traditional approach that you might take. So you're just going to embed that AWS SDK in your Heroku app, create IAM users with minimal permissions, and attach policies to those users that reflect those permissions. So let's just say I was creating an app where I wanted to be able to read and write from a specific S3 bucket or prefix. I'd create a policy which restricted access to that particular S3 bucket or prefix. I'd create a user in the IAM console, attach that policy to the user, download the access and secret key, and then use that access and secret key within my environment. And all requests made with that access and secret key would then have that restrictive policy applied to them. It's a very simple use case. But the same thing applies to Kinesis, to DynamoDB, to invoking Lambda functions, to starting containers on ECS, to any other operation that you want to perform through one of the AWS managed API endpoints. You're going to use that access and secret key, an IAM principal, and a policy to do so. So it's a really simple process to integrate AWS services together with Salesforce Heroku. But there's an important takeaway. On the bottom of this slide, which I hope you can all spot at point 4, use config vars to embed these into your environment. Do not embed them within source code, okay? Because what happens to source code? It gets shared, checked into repositories. Bad guys scan those repositories 24 hours a day. They steal those access keys, and they use them to run compute jobs at your expense. So don't check your IAM access and secret keys into GitHub, okay, or GitLab or any other public source code repository. One of the best ways to avoid that is to strip them out and use environment variables to set them. And that's actually common for Heroku or for other AWS services like Lambda or ECS, actually, that we support environment variables broadly as a mechanism for getting access to credentials. So they don't need to be provided as part of a source build. We actually have a tool on the AWS Labs GitHub that can scan Git repositories using regex to look for AWS credentials and warn you if you do check them into a repository. So you can also check that out if you're interested as well. That's github.com/AWS Labs. Okay, so that's all I have. I'm going to turn this session over to David now from Salesforce Heroku, who's going to talk a little bit more broadly about the partnership that we have. David.
Thank you. Thanks. Hello. I think my microphone works. Excellent. You can all hear me. The laser works as well. My name is David. The most important takeaway from the slides you just saw: always use config vars, environment variables as the so-called 12-factor principle. You can read about it on 12factor.net. And if you build applications that way, don't assume the file system is persistent. Don't store your secrets in your code. You make A, your development life a lot easier, and B, you're ready to run in any environment, right? So it doesn't have to be something like Heroku. It could be Docker, super easy, environment variables and containers, and any other environment. I'm going to talk a little bit more high level about AWS, the relationship to Salesforce, how Heroku fits squarely in the middle, and can help you make your life a lot easier. My name is David, and so Heroku is a Salesforce company. We have been for many, many years, proudly a member of that family. And the relationship between AWS and Salesforce goes back many years, and we have, over the years, grown more tightly together. The AWS folks on the one side now very happily, at least I hope so, use Salesforce products such as the Sales Cloud for their day-to-day activities. And at the same time, Salesforce is shifting more and more systems and applications to AWS infrastructure, because Salesforce was one of the original cloud applications, right? Software as a service in the 90s before AWS was around. So obviously, we still run our own data centers. But newer products, such as Quip, which you may have used, newer Salesforce platform elements, or, of course, very notably, the Heroku platform itself, have always run on AWS, right? And we keep adding elements to that partnership, and we keep growing more closely together, because we see a lot of customers come to us from either direction, right? So you have, the laser is not, there we go. So we have a lot of existing customers in Salesforce who are on the pure software as a service layer, right? So they run their business and their day-to-day operations, but eventually, because the buzzword of the day is Internet of Things, big data, knowledge, right? They want to make more sense of their data. So they eventually start building custom solutions on top of the Salesforce platform that exceed the capabilities of that platform, where they can no longer use the technologies the platform gives them, and they have to use something generic. They have to hire somebody who knows how to write Java code, Python, PHP, Node.js, and build logic, for example, to shovel data from a factory into their CRM, right, to update order statuses or something. And their factory software system is old and legacy, but there is some sort of database, so somebody can make that magic happen. And that's when they start moving more towards like the platform side of things. And eventually that data hopefully grows larger and larger, so they will require one day, because the business is successful and everything's growing, technologies like DynamoDB or Redshift, where they do data warehousing in AWS. And at the same time, a lot of Heroku customers eventually, because they build little startups, they build their sites and app backends and everything on the platform, eventually they need a CRM, so they move up. And eventually, their systems become more complex, so they move down in this list that you see, and they run more and more of their infrastructure aspects on the infrastructure layer that AWS so proudly provides, with like the dozens and dozens of different capabilities. You saw the huge slide earlier that Ian showed with all the different features, right? So we'll hear later from Rick about how the Financial Times built ft.com using a very similar approach. But Heroku itself is and always has been built fully on top of AWS, right? Like, we're very tightly integrated, very happy, we have to say. And it makes sense for all of our customers to experience the full breadth of that integration, because these three are category leaders in their marketplace, right? Like, Salesforce is the #1 CRM and SaaS software. Heroku is the #1 platform as a service, and AWS is very clearly the #1 infrastructure as a service provider. So by tapping into each of these three systems, our customers get a lot of synergies when they build their systems, because the next step in evolving anything, be that on the business side with a marketing cloud add-on or a support cloud, or you need an online shop, there's now formally Demandware, now the Salesforce Commerce Cloud, and then you can pull data down into your mobile app backend that runs on Heroku, and then make sense of it all using Redshift, and move your core API eventually down to raw infrastructure instead of running it on us. All these things happen all the time. It's very fluent transitions now between these layers, right? And Heroku itself is, well, as a platform as a service, mostly focused on developer productivity, right? So we want people not to worry about, at least for quick experiments when they get started on projects, there is a mental barrier in developers' minds that causes them to not even start an experiment. Because they think, well, we could refactor the website to be faster, but we need Elasticsearch for that, and we don't know how to set that up, so we'd have to sit somebody down, and we're so busy right now. Also, should we be using Redis or something else for caching, and we don't have the expertise to set it all up. But we want people to just write code and deploy it, and not worry about the underlying infrastructure. And obviously, that's not possible for all applications, right? Heroku is not a platform for machine learning applications or for 3D rendering of something. But anything that touches the web, anything that can act as glue between systems, anything that's a mobile backend for your iOS or Android applications, where you need the full flexibility and scalability of the cloud, but at the same time, you don't want to sit down 5 hours before you can start building a project because you had to set up Chef or Puppet recipes for orchestration first. That's what we do, right? Because on the core, we still run on AWS, but you don't actually see that as a customer, although you can still interact with it. I'll get to that in a second. So everything runs in containers. We call them dynos, right? And they're built by the second. So if you run 50 of these for 22 seconds, we only bill you for 22 seconds of your time. And then we support any modern programming language, PHP, Java, Ruby, Python, .NET. No, not .NET. That's the sole prominent exception. Go, Scala, whatever. And then we maintain those, right? Like, so we provide you with updates, so the next time you deploy the code, you get the very latest language runtimes. In the meantime, if on a Saturday night an SSL vulnerability hits the world again, your developers don't wake up. We wear the pager, and we patch the underlying systems for you, so you can be sound asleep or drinking in a bar. And then we have all the data stores that we provide. So we run our own Postgres service, Kafka, and Redis. And then we have all the add-on providers that provide value on top of the platform. And that's a really, really important aspect of Heroku's offering, is that if you're building an application and you're not really sure if you should be using MongoDB or something else, you just try both and you provision both. And it's literally one command or 2 clicks in the dashboard, and you immediately have that capability as a developer. And think about the opportunity cost associated with developers managing all this infrastructure just for an experiment, just for a development test bed, just for a new staging environment, just for the refactoring of a website. The mental barrier that says, I could try this, but it's complicated and I don't have time to research it all, goes away completely. So you start out with the add-ons, and then hopefully you run on them forever. But sometimes our customers outgrow the capabilities of our platform or of our add-on partners, and then they move some of the system parts down the stack and run it on their own managed infrastructure, their own being, it still runs on AWS, at least hopefully. And that's the success story that the Financial Times has to tell in a couple of minutes. But yeah, and then to integrate with Salesforce, if you're a customer, there's the so-called Connect add-on. So you can map arbitrary objects from, say, your CRM into an SQL database, and then you just take a developer, sit the developer down and say, here's a table called contacts, and it has a field first name, a column first name, last name, email address, etc., and they can immediately make sense of it, right? And then you build amazing applications that integrate with your sales applications, etc., in Salesforce, where, you know, if I update my shipping address on your mobile shopping app, it updates it in the CRM, and if the CRM computes a loyalty gold something status for me, it's immediately reflected on the website. So yeah, those are basically the benefits. Here's another little summary. But always think about what does developer time cost, right? I'm an engineer. I know that my people have no idea what their own time is worth or what their own time is costs, right? Like we have a little bit there's a bit of a blind spot for us to understand that if we spend 5 hours or 10 hours per week managing some sort of server configuration or et cetera, we don't immediately think about what value could we be providing the business in that time. And as business owners, managers, et cetera, they're always interested in, build me a feature that makes me more money. So that's the big takeaway. And then eventually, hopefully you run a complex system and you can always extend it, right? It's not a proprietary system. You can always move stuff on and off it with relative ease. And of course, tap into the whole wealth of the AWS ecosystem. So Ian had the example earlier where you just, you create a Redshift DB, you create an S3 account, bucket, something like this, and you have credentials. You can set them on your Heroku application, and then the code just talks to it. Because as far as your code is concerned, it just runs on a server that you simply don't have to worry about, right? And then the interface becomes really, really interesting. So we see a lot of customers now coming from this side because they say, we're really, really happy there, but we want more experimentation and more brave, crazy experiments that our people do. So for some parts of our development, we want the PaaS experience and the developer experience for our developers and easier management. And at the same time, it happens to practically all of our customers that eventually they want to, use simple email service, simple queue service, something that Amazon has to offer. CloudFront is a very prominent example that many, many, many of our customers run. So you just tack them on top of it. And because we also run on AWS, you run in the same regions, low latency, very little overhead. And if you want, and you run in one of our so-called Heroku private spaces, you can also pair your VPC with the one we give you, right? So in a Heroku private space, you don't run on our shared infrastructure, but we give you your own complete infrastructure, your own routing, your own database and servers, et cetera. You share no instances with any other customer. You can do whatever you want in your network, and you can tap into the existing VPC through peering that you already have set up. And then it looks like one network to your applications. And you can build a lot of very, very powerful stuff. One very, very powerful thing that we've seen was built by the Financial Times. So I now welcome up Richard to talk about how they did that.
Hi, everyone. So I'm Richard Still, and I'm a technical director with the Financial Times. And I'm responsible for all of the FT's customer-facing products. And of course, chief among those is ft.com. Last year, we relaunched the website to great success. And I'm going to talk today about our approach to technology and how that was fundamental to the success of the new site. So the FT is, of course, a leading publisher of financial news. We have over 840,000 paying subscribers, and 650,000 of those are digital only. So we're very well traveled on the journey to kind of digital publishing. So technology is incredibly important to us. We're 128 years old, but we can't afford to be old in our approach to technology and how we use it. Incredibly important for us is that all of our content sits behind a paywall, and the FT would not be able to survive as a kind of modern leading news publisher if that wasn't the case. So this is a snapshot of the new site. It's entirely built on AWS and Heroku infrastructure. And I'll take you through some high-level features of the kind of success, if the clicker works. So the FT is a fundamentally data-driven organization. So data is at the heart of everything that we do. And I don't just mean kind of operationally in terms of making sure that our systems are running correctly, but it informs everything we do commercially as well, understanding how users are using our products and their level of engagement drives our product development process. And the new site, we saw a 20% uplift in engagement. Advertising is still incredibly important to us. We have a, let's say, quite wealthy set of users, and being able to leverage what we know about users and sell targeted advertising, again, is really important to us as an organization. And the new site, again, a 72% uplift. I'll go a little bit nearer. Okay. So the FT is the fastest site in the industry. We use speed curve to measure that. So on desktop, we're around 1.3 seconds. On a mobile, we're around 2. And this is, of course, partly due to the approach to technology, but it's also because performance has become an incredibly important part of the way that we work. When we first launched the new site, we actually performed a split test to see what the commercial impact of a fast site versus a slow site was. I can't show the exact numbers, but as we slowed down the new site compared to the old one, we could see that the drop in engagement was significant. And as engagement drops, consumption drops. And as consumption drops, so do subscriptions. And the value of our kind of users goes down. Sorry. I'll try not to wander about too much. Okay. And return on investment was 50%. This is in no small part because we were able to work so efficiently. So we have 3 pillars, really, that underpin how we managed to deliver the new FT site. Today, I'm just going to focus on the tech. That's not because our approach and the people are not as important. They are, but we're limited in time. So the new site was actually a greenfield opportunity for us, and I don't just mean from a technology perspective, but also from a kind of engineering team and a cultural perspective. So culture was actually the first place that we started. We are quite well traveled on our journey into the cloud, but we wanted to take it to the next level. So everyone involved in the rebuild of FT.com kind of had started with a born in the cloud mentality. Everyone involved as well, and I don't just mean engineers, designers, UX, product owners, had to have a real bias for action. We needed problem solvers. And that was, again, critical to kind of having these kind of autonomous teams. We needed to be able to innovate at speed. The publishing industry as a whole is under a great amount of pressure. So we couldn't just deliver at speed. We had to be able to innovate, try new technologies quickly, try features quickly, understand if they work. If they didn't work, we can kill them off. If they do work, then we can build on those and move forward. We have an enormous preference for as-a-service style technologies, whether it's platform as a service, infrastructure, or software. We really want to focus on delivering value for the business. We don't have the kind of scale, obviously, of someone like Google or Apple. We absolutely had to spend the engineers' time in the most efficient way that we possibly could. And talking of engineers, all of our engineers are full stack, so we're working on the presentation tier. We use Node.js as our primary language, so all the engineers can work across pretty much any part of the stack. And again, because we've chosen to use mainly as-a-service style technologies, we don't have to embed a load of deep knowledge about how to operate technologies like Elasticsearch or MongoDB or DynamoDB. All of these technologies can be handled by the vendors, or operating them can. So our tech choices, every time we look at a piece of technology and want to achieve something, first and foremost, they have to meet our cultural guidelines. There's a few other things that we knew we wanted right from the start. We wanted continuous delivery. This comes back to the point about shipping quickly and innovating quickly. And we wanted to follow modern software architecture principles and modern approaches to software development. So David already mentioned the 12-factor app methodology, and that's something that we've followed closely. I'm not learning my lesson. So the P word, it's a little bit of a dirty word in FT with engineers, and it's actually procurement. It's very tedious, I know. It's a very important process to go through, especially if you're a big organization, but it can absolutely stop you in your tracks if you're trying to innovate. So the last thing you want, once you've spent the time and effort building up your incredible delivery team, is for them to stop dead in their tracks while waiting for a piece of technology to move through a procurement process, which can take quite a long time. So, and I mean weeks or months. So AWS is enormously helpful here. It has a big product portfolio suite now. So there's a good chance you might find the technology that you need in there. Heroku is also helpful. You still have to go through a kind of diligence process with the technologies in the marketplace. But you have a centralized billing mechanism that makes life easier, and you know that Heroku have done some due diligence up front. So what we built was the presentation tier of FT.com. But to complement that, we built a new real-time analytics platform. And because email is such an important engagement channel for us, we also built a new email platform as well. Okay, so we follow a microservices architecture across the entire state of those 3 platforms I've described. We have perhaps hundreds of applications. We release to production perhaps 10 to 20 times a day, depending on how busy we are. I've mentioned the 12-factor app methodology, and of course we instrument everything for our own operational needs using Graphite. And again, we're using a hosted Graphite solution rather than running our own. I will not learn my lesson. Okay, so this is an incredibly simplified snapshot of what FT.com looks like. You can kind of see that all of the executing code is running as Node.js in Heroku containers. We have Elasticsearch, which underpins pretty much every part of the presentation tier, and we have a presentation-specific view of our content, the entire repository there. And in the real-time analytics pipeline, we're using a suite of AWS technologies. And again, this is so that we can act quickly on the data that we get. So something that NGDA, which are next generation data analytics platform, and the email platform have in common is that you can buy solutions for these off the shelf, actually. The problem there, at least for us, is that you tend to get a lot of bloat. And the features that you do get, if they tick all of your requests, quite often there's not a precise match. So you kind of have to compromise, and quite often you pay for a load of features that you don't actually need. So what we did in both of these examples is we looked in the market for the kind of best-in-class vendors who can do the heavy lifting that we needed to do. So the FT as a business does not care about the logistics of delivering 500 million email messages. It's just, there's no value in that for us. So we looked about, we thought, who can be the best? Who's the best in the marketplace? Who's kind of modern, API-driven, scalable? And we chose a vendor, and then we built incredibly targeted functionality on top of that vendor. So we were able to very explicitly meet the needs of the business very quickly and using a very small team. And the same was true for NGDA. The vendors that we had looked at and we were using that were all in one, none of them did exactly what we needed to do. So we took the heavy lifting parts and we built the value add. I'll get there eventually. So a little bit about our stack. We only have one environment for FT.com, and that is production. And this is really valuable for lots of reasons. It's incredibly cost effective from an infrastructure perspective. You don't have to pay the cost of lots of different environments. But going back to something that David said, you don't take an opportunity cost hit. So developers are not worrying about having to maintain data across multiple environments. They're not having to worry about whether lower environments meet production well enough to function. So devs can just get on with the business of developing features. And importantly, with Heroku, that was actually really easy to do. The amount of tooling that we've built to get our continuous delivery and continuous integration pipeline up and running is actually really small. It's perhaps 1 or 2% of our entire capacity to have this up and running, and it's one of the first things that we built. And that's because, again, the heavy lifting has been done for us. So for those that don't know the details of Heroku, it has this concept of a dyno, which is a lightweight container in which your code is executing. You kind of get the small, cheap ones, which are called standard dynos. They have fairly small amount of compute and memory. They're fairly high contention, but they're cheap and they scale out very easily. And then you have performance dynos. So for the most part, FT.com is running on these small, cheap standard dynos. Anything that is on the critical path, we pay that bit more and we run it on a performance dyno, because what we see is that lower contention means we get more consistent performance across the board. Now Heroku initially came as an add-on with Salesforce. And our journey with Heroku was we kind of tested the water. We had it for perhaps 3 or 4 years before we started using it on FT.com. And when we spun up FT.com from scratch, the team, Heroku was naturally the first choice because of all of the reasons about not wanting to kind of operate anything and be able to get up and running incredibly quickly. But actually, we fairly quickly discovered that Heroku didn't just need to be a playground. The amount of effort that we did not have to put into operating the beta website, and we ran a beta website for 18 months before we went live, was enormous. And so we took the decision at around 50% of traffic that actually Heroku was fine for us as a platform. There was one major concession. We run everything that is critically important to us in more than one region. As you all probably all know, AWS does have the occasional wobble. There's been a couple this year. Heroku also has the occasional wobble. Everyone has a wobble every now and again. But by running in multiple regions, we managed to kind of mitigate that risk for FT.com. So when AWS had its big S3-based outage, we weren't actually affected at all. I kind of mentioned the lack of tooling. It's really important to kind of emphasize just how little we have to do to operate our stack. That's not to say we have no operational overhead at all. Of course we do. But we're not doing any of the kind of heavy lifting of operating proprietary technologies like Elasticsearch. So these are just some of the AWS technologies that we use. What's common to all of these is that it takes a very small amount of effort to get up and running. It takes a very small amount of effort to scale, assuming you need to do any effort at all to scale, which you obviously don't with lots of things like Elasticsearch with S3. And they all have a very low operational overhead. So Elasticsearch, we've scaled it up and down many times, whether we're dealing with kind of problems in our code or whether we're dealing with huge spikes in traffic. We can simply, within a few minutes, have doubled the size of our cluster. We have no idea how that actually is happening under the hood, but we don't care. The point is we're able to meet the objectives of the business and we're able to kind of provide an excellent service to the rest of the business without us really having to put any effort in there. So DevOps has been quite a long journey for the FT. And what we've actually found is with technologies like Heroku and with these low overhead technologies from AWS, is that it's really accelerated the DevOps journey, because a lot of the tasks that are traditionally the remit of first and second line support aren't really relevant anymore. So we never have to worry about patching a container in Heroku. We never have to worry about log files filling up. We never have to worry about kind of vulnerabilities, because as David mentioned, Heroku is wearing the pager. We're not doing that. So third line engineers are far happier to be on the hook for problems with FT.com, because they know actually it's far more likely to be something that they've done and they're proud of what they've built, and they're not worrying about a kind of hand-rolled container system that may or may not be as good as Heroku, almost certainly wouldn't be. And so they're kind of happy to be phoned at 3 o'clock in the morning. Well, perhaps not that happy to be phoned at 3 o'clock in the morning, but they're much more happy than they would be if they were being phoned up because, like I say, a log file has filled up the hard drive. So to wrap it all up, the publishing industry is under a huge amount of pressure, and we all have to be able to innovate to survive. We have to be able to ship to survive. And these kind of technologies, combined with our approach to using them, our approach to people, and our approach to how we develop our products and services, are kind of fundamental to our success. We have an absolutely kind of tight focus on delivering just the value that the business needs. We're not trying to reinvent the wheel. And the kind of choice of technology really is kind of key to innovation and key to survival for us. So that's it. We all lived happily ever after. If you've got any questions afterwards, please let me know.